In the vast expanse of our solar system, there exists a realm of endless wonders and mysteries. Among these celestial marvels, a moon named Titan has captivated the imaginations of scientists and dreamers alike. Titan is Saturn's largest moon, a giant among its peers. It is a world shrouded in mystery, with landscapes that seem almost otherworldly. Recent discoveries have hinted at the tantalizing possibility of extraterrestrial life. This revelation has sent shockwaves through the scientific community, sparking intense debates and discussions. It has ignited a firestorm of speculation about the nature of life beyond Earth and what it might look like. Titan stands apart from other celestial bodies in our solar system, a unique gem in the cosmic ocean. It possesses a dense atmosphere, a rarity among moons, making it an object of great interest. Even more intriguing, Titan boasts lakes, rivers, and even seas on its surface, a feature that is both fascinating and perplexing. However, these bodies of liquid are far from ordinary, adding to the moon's enigmatic allure. They are not composed of water like those on Earth, but something far more unusual. Instead, they are filled with a chilling mixture of methane and ethane, hydrocarbons that are typically gases on our planet. These hydrocarbons exist in their liquid state due to Titan's incredibly frigid temperatures, which create a unique environment. These temperatures plummet to a staggering -290 degrees Fahrenheit or -179 degrees Celsius, making Titan one of the coldest places in our solar system. As scientists plan future missions to explore this enigmatic moon, the world watches with bated breath, eager to uncover the secrets that Titan holds. Could Titan be a future home for humanity, or will it reveal life forms unlike anything we have ever imagined? Only time will tell. Titan's extraordinary environment presents a unique challenge to our understanding of life. Life, as we know it, depends on liquid water. Water acts as a solvent for essential molecules and facilitates the complex chemical reactions necessary for life's processes. So, how could life possibly exist in a world where water is frozen solid? Scientists have been investigating the possibility that life on Titan, if it exists, might have found a way to thrive in this alien environment. The key to this hypothesis lies in the chemical composition of Titan's lakes and seas. While methane and ethane dominate the liquid landscape, they are not the only players in this extraterrestrial soup. Scientists believe that a diverse array of organic molecules, the building blocks of life, could also be present. One particular molecule has caught the attention of researchers: acrylonitrile. Acrylonitrile is a small, simple molecule composed of carbon, hydrogen, and nitrogen atoms. On Earth, acrylonitrile is used in the production of plastics and synthetic fibers. However, on Titan, it has been proposed as a potential key ingredient for life. The hypothesis centers around the idea that acrylonitrile could form cell-like structures in Titan's methane-rich environment. These structures, known as azotosomes, would be fundamentally different from the cell membranes found in life on Earth. However, they could potentially serve a similar purpose, acting as barriers that separate the internal environment of a cell from the external environment. To test the plausibility of acrylonitrile-based life forms, scientists turned to computer simulations. These simulations allowed them to recreate the conditions on Titan's surface, albeit on a much smaller scale. By inputting the known properties of acrylonitrile and the environmental parameters of Titan, the researchers could observe how the molecules interacted with each other. The hope was that the simulations would reveal acrylonitrile molecules spontaneously assembling into flexible, membrane-like structures. Such a finding would lend significant credence to the idea that life could exist on Titan. Section 5. Surprising results: a crystalline structure. Instead of forming the flexible membranes that researchers had hoped for, the acrylonitrile molecules in the simulation exhibited a surprising behavior. They arranged themselves into a rigid, crystalline structure. Crystals, while beautiful and fascinating in their own right, are not conducive to life as we know it. They lack the fluidity and adaptability that characterize cell membranes. This unexpected outcome raised more questions than it answered. Did this mean that life on Titan was impossible after all? Or were there other factors at play that the simulations had not accounted for? The scientific community was divided, with some researchers interpreting the results as a setback for the possibility of life on Titan, while others remained cautiously optimistic. Section 6. The debate rages on. The debate hinges on the interpretation of the simulation results, which have sparked intense discussions among the scientific community. Some scientists argue that the rigid crystalline structures observed in the simulations are a deal-breaker for life on Titan. They believe these structures are too inflexible to support the dynamic processes required for life. They contend that the formation of flexible membranes is a fundamental requirement for life, and that the absence of such structures in the acrylonitrile simulations suggests that life as we know it cannot exist in Titan's environment. Without these flexible membranes, cellular functions would be severely limited. Others, however, are not so quick to dismiss the possibility of life on Titan. They argue that the conditions on Titan might allow for alternative forms of life that do not rely on the same biological structures as Earth-based life. They point out that the simulations, while sophisticated, are still just simulations. These models, although advanced, cannot capture every nuance of Titan's unique environment. They are not perfect representations of reality. The limitations of current technology mean that some variables and conditions might be oversimplified or overlooked. There may be factors at play on Titan that the simulations did not or could not account for, factors that might allow acrylonitrile to behave differently in its natural environment. These unknowns leave room for the possibility that life, in some form, could exist on Titan, challenging our understanding of what life can be. Section 7. Alternative theories emerge. In addition to the ongoing debate about the implications of the acrylonitrile simulations, alternative theories about the nature of life on Titan have begun to emerge. These theories challenge our conventional understanding and push the boundaries of what we consider possible in the search for extraterrestrial life. One such theory proposes that life on Titan might not rely on cell membranes at all. This idea is revolutionary, suggesting that life could exist in forms vastly different from those on Earth. Instead, it might exist in a form completely alien to our current understanding, perhaps as a self-replicating network of molecules or as a form of life that utilizes a different solvent altogether. This would mean rethinking the basic building blocks of life and how they interact in extreme environments. Another intriguing possibility is that life on Titan might exist not on the surface, but deep beneath it. This theory opens up new avenues for exploration and research, as it suggests that life could be hidden away from the harsh surface conditions. Scientists have long speculated about the potential for a subsurface ocean of liquid water on Titan. This hidden ocean could provide a stable environment where life might thrive, protected from the extreme cold and radiation on the surface. This ocean, if it exists, would be located beneath Titan's icy crust and could potentially harbour life as we know it. The discovery of such an ocean would be a monumental step in our quest to find life beyond Earth, offering a new perspective on where and how life can exist in the universe. Section 8. The search for subsurface oceans. The search for evidence of a subsurface ocean on Titan is ongoing. Scientists are using a variety of techniques to study Titan's interior, including analyzing its gravitational field and observing how it interacts with Saturn's magnetic field. These observations have provided tantalizing hints that a subsurface ocean might indeed exist, but conclusive proof remains elusive. If such an ocean does exist, it would have profound implications for our understanding of the potential for life beyond Earth. It would suggest that even in the most extreme environments, where surface conditions seem utterly inhospitable, life might find a way to thrive in hidden, protected niches. Section 9. Titan's dynamic landscape. Adding to the intrigue surrounding Titan is its surprisingly dynamic landscape. Titan experiences seasons much like Earth, albeit on a much longer timescale. These seasons drive changes in atmospheric circulation and weather patterns, resulting in the formation of clouds, rain, and even lakes that expand and contract over time. This dynamism suggests that Titan is not a static, unchanging world, but rather a place of constant flux and evolution. Such an environment could potentially provide opportunities for life to adapt and diversify, perhaps leading to the emergence of life forms even stranger and more wonderful than we can imagine. Section 10. Expanding our horizons. The search for life on Titan is ultimately a quest to understand the nature of life itself. By exploring the possibilities for life in such an alien environment, we are forced to confront our own biases and assumptions about what life is and where it can exist. Whether or not we ultimately find definitive proof of life on Titan, the journey itself is invaluable. It is expanding our horizons, challenging our preconceived notions, and inspiring us to imagine the boundless possibilities of life in the universe. And that, in itself, is a discovery worth celebrating.